Go. All right, we're going to talk about section 10.7, which are spheres. We talked a little bit about spheres before. They're ball-shaped, solids. They're a perfect circle. And I put this picture on there because I really liked the way it illustrated what a sphere was. It's got a lot of pieces to it that you might not know of. So you see this big orange area in the middle here. It even has an arrow that goes around. This right here, this orange part, we actually call it the great circle of the sphere. And in our Earth, that great circle is called the equator. So every sphere, if it's a perfect sphere, has what we call a great circle. It's the biggest circle that you could make on a sphere. Because you could make circles going up the sphere all the way to the top. But these would be little circles up at the top. But the biggest circle that you could make, we would call the great circle. Now, they've got this big pi r squared in the middle. They've got a radius here. What does the pi r squared represent to us then? It's the area of the circle, right? Area of this circle in orange. They've also got arrows going around, and they've got 2 pi r underneath. What does that represent? Circumference of the big circle. Okay, so we got those two. Now, there's 2 formulas left. One of them is surface area. One of them is volume. You've got a 4 pi r squared. You've got a 4/3 pi r cubed. Which one do you think is surface area? Okay, the top one is correct because square units, surface area is always measured in square units. So your 4 pi r squared is going to be your surface area. Your volume then is going to be your 4/3 pi r cubed. 4/3 pi r cubed. So basically, the surface area is 4 circles. Now, here's a sphere right here. Okay, I'm going to show you the illustration of a baseball. Now, you might notice that there's circular shapes right in here. Okay, there's 1, there's 2, there's 3, and there's 4 of them. So when they cover the baseball up, they're basically using 4 circles to do that. So you see how the formula here has 4 pi r squared. So to cover a ball, you need 4 circles. So let's find out the surface area of the sphere there at the bottom. We are going to use our formula, 4 pi r squared, and we're going to plug in what we know. 4 times pi, which is pi, and then 4 is our radius. So you've got 16 times 4. You've got 64 pi. Now, it's okay to leave answers in terms of pi. When we get to trig, we're going to be seeing all of our answers. Most of our answers are going to be left with a pi in the answer. But right now, I'm going to go ahead and multiply it out. And let's see what we get. 64 pi. We get 201.06. And that would be in square inches, because we're talking about surface area. If you miss anything, of course, you can go back online later and get it off the video. I'm going to go ahead and keep moving so that we can try to finish. Okay, example 2. Now we have found the surface area, 4 circles. Now we're going to look for the volume. How much would it take to fill up a sphere? And that would be this formula right here. The 4/3 pi r cubed. I would actually prefer writing it like this, and you're going to see when I write it, I'm just going to put the 4 pi r cubed on top and divide everything by 3. To me, that's just easier to do, rather than worry about the 4/3 fraction in front. So I'm going to fill in what we know. Pi, or 4 times pi times 2.5 cubed, and then divide it by 3. Okay, so your volume here is going to be 65.45. And that would be in cubic feet. So again, most of these solids, all you have to know is the formula. You can plug numbers into the formula, you can put them in your calculator, you can get the right answers. But you've got to make sure you're using the correct formula. For this one, it's the 4/3 pi r cubed. Okay, moving on. Example, first one is a real-life example about the Earth. it's approximately 3,960 miles is our radius. So from the core of the Earth to the surface of the Earth, it's approximately that many miles. That's not saying that exact. So that means if I went straight through the Earth, through the center of the core, all the way to the other side, to get the diameter, it would be double that. That would be 2 of the radii. So let's find out what the surface area of our Earth is. So we're going to use the 4 pi r squared, 4 circles. 4 circles covers a sphere. So it's going to be 4 times pi times 3960 squared. It's going to be a pretty big number. But to cover our Earth, it's going to have to be a big number. Bless you. 3960 squared times 4 times pi. You get 197,060,797.4. And that would be in square miles. So we would put mi squared, square miles. How many square miles would completely cover the Earth?
Not that much.
Pretty good number. All right, a fully inflated weather balloon has a diameter of 12 feet. Diameter means straight across, all the way across, from one side to the other. Diameter is 12. Suppose 1/2 of the air is lifted out of the balloon, or is let out of the balloon. So right now the balloon is fully inflated, it's got a diameter of 12, and then you let out half the air. They want to know what's going to be the new diameter. Is it going to be cut in half? Since you cut your volume in half, is that going to cut the diameter in half? That's basically what we're looking at here. So let's test it and see if it's going to come out as half. Let's find the volume of the fully inflated balloon. So 4 times pi times my radius is how much? 6. Good. So the radius is 6. So cubed and then divided by 3. So let's see what our volume is going to be for the fully inflated one. So 216 would be 6 cubed times 4 times pi divided by 3. 904.8. Sorry, 904.8. That would be in cubic feet. Now what did we do to the volume? We let out half of it, didn't we? We let half of it go. So we're going to divide this by 2. And our new volume is now going to be 452.4 cubic feet. So that's our new volume. They want to know, what did that do to my radius / diameter? We got to test it. So let's put our new volume in and put it equal to our formula. And let's see if we can solve for r to see what it did to the radius. What kind of radius would have this volume, and then we can double it to get our diameter. So first thing let's do is multiply by 3. So those will cancel out. And let's see, times 3 here. You get 1357.2 equals 4 pi r cubed. And I'm going to divide by 4 pi, but I'm going to put that in parentheses. So I divide by the whole amount of 4 pi. So divided by 4 pi. And you get 108. So you get 108 is what you get when you divide that by 4 pi. And that equals r cubed. So r times r times r equals 108. How do I figure out just what r is? Cube root it. Yes, I'm going to do the third root. Third root of 108. So you might have a button on your calculator that's got the square root with a little x on it. So you need to hit the 3 first, then you hit that button. Then you put in 108 and then equals. And you get 4.76. So my radius is 4.76. If I double it, that will give me my diameter. 9.52. So when I took out half my volume, did that make my diameter get cut in half? No, it's more than that. It's 9.5. The diameter, half of the diameter would have been a new diameter of 6. Now I got a new diameter of 9.5. So just as you take half the volume out doesn't mean you're cutting the diameter in half. Yes. Okay, moving on. Like I said, you can get these later if you need to. Okay, radius of the sphere is doubled. If the radius is doubled, what happens to the volume? Easiest numbers to use would be a radius of 1 and a radius of 2. So let's find out the two volumes if I have a radius of 1 and a radius of 2. Volume would be pi times 1 squared. No, sorry, I forgot the 4. We're doing the volume formula. So 4 times pi times 1 cubed over 3. This volume would be 4 times pi times 2 cubed over 3. So if I do my two volumes here, let's see what we end up with. 4 times pi. 1 cubed is just 1, so I'm just going to leave 4 times pi. And I'm going to divide that by 3. 4.2 is what you end up with when you round it off. 2 cubed is 8, so 4 times 8 times pi. And then divide by 3. Get 33.5. So did the volume get doubled? I doubled my radius. So what happened to the volume? It got way bigger. Like how much bigger? Like 10 times bigger? Oh, like 8 times bigger is right. It's about 8 times bigger. You know why? Look at this number and look at this number. 1 cubed is what? 1. 2 cubed was 8. It got 8 times bigger. So you could just take the new volume, the volume you got, times it by 8, and you'd have the other volume if you doubled it. 8 times more, because we're cubing it, because we're always in cubic units. Okay, diameter of a spherical water tank is 30. So let's say that we've got a water tank. The diameter is 30. There are approximately 7.48 gallons of water. How many gallons of water will the tank hold? Well, we need to find the volume first. And actually it says the diameter is 30. I'm sorry, so this all the way across would be 30. So what's my radius then? It's 15. So my radius is 15 feet. So let's see, we're going to do our volume formula. 4 times pi times 15 cubed divided by 3. It's going to be a pretty big number because 15 cubed is a pretty good number. And then you're going to multiply that by 4. You're going to multiply that by pi. And you're going to divide that by 3. 14,137.2. Okay, that would be the number of cubic feet. That's the volume. I did all this right here in my calculator and got this one. Now, each one of these cubic feet can hold 7.48 gallons. Every single one of those 14,000 could hold 7.48 gallons. So how many gallons of water can go in that tank? What do I have to do? Divide. No, you're going to multiply each one of these. Each one does 7.48. Every single one of those does 7.48. You got to multiply that by 7.48. You're going to get 105,746 gallons. That's how many gallons would fit in that tank. Now let's see, 1 cubic foot of water. So if you got 1 little cubic foot and it's filled up with water, it weighs 62.5 pounds. So every single one of these cubic feet weighs 62.5 pounds. How much would that whole sphere weigh if it was filled up? What do I have to do? Multiply again, good. 14,137.2 times 62.5. So 14,137.2 times 62.5. Hold on one second. Get 883,575. That's how many pounds that sphere would weigh. So the cubic feet that we found that was inside of the sphere was 14,000 cubic feet. Each one of those carried 7.48 gallons, so total gallons was 105,746. Each one of these also weighed 62 pounds. So we got to multiply it by 62 and a half, and you get your total pounds, your total weight. I have to do the last ones really quick. So I know that we're going to move on, so here they are. You can watch those back later if you need it. It says a cube is enclosed by a sphere with a radius of 8 centimeters. So that means this is 8 right here. If that's 8, then how long is the cube if the ball fits it perfectly inside? Got to be 16 across. 16 this way and 16 this way because it's a cube. So it's going to be 16 on all 3 sides. Find the volume of the cube. The volume of a cube we learned was side cubed. So in this case it's 16 cubed, which is 4,096 centimeters cubed. That's how much would fit inside of the cube. Not the sphere, that's the cube. So if I wanted to put a bunch of little centimeter cubes in there, I could fit 4,096 of them. Now we want to find the volume of just the sphere. So we're going to use our formula 4 pi r cubed over 3. It would be 4 times pi times 8 cubed over 3. Because the radius is 8. So I'm going to do 8 times 8 times 8. I'm going to multiply that by pi and by 4. I'm going to take that number and divide it by 3. The volume in the sphere is 2,144.7 cubic centimeters. The last question says, what's the probability that a point chosen at random will lie between the sphere and the cube? Well, let me show you this. If you took your sphere, which was 2,144.7, and divided it by the cube, 4,096, you would get 0.524. Okay, you move that over 2 places, that's approximately 52.4%. What's that the probability of? Is that the one I want? That's fine. Yeah, that's landing in the sphere. What is it asking me? What's the probability that would be between the sphere and the cube? So what do I need to do to that 52.4%?
100
Subtract it from 100. Exactly. Yep. Yep. 100 minus 52.4. You get 47.6% chance. That would be your probability that you'd pick a point that's in the cube but not in the sphere. 52% chance that it would be in the sphere. So you can kind of see that a sphere is a little more than half of the cube filled up. Not quite, a little bit more than half is what the sphere would be.